All right, so as I said, nerves. What is nerves? Let me recapitulate some of what I told you guys 2 years ago and give updates. So a lot of you probably have played with Ruby, Elixir in addition to Ruby. It's a lot of, how to say, changeover, switch over between these communities, crosstalk. Let's actually see how many have used Elixir. That's a good amount. I would say a third, maybe. Has anybody used Nerves? One. Good. Good. I want to talk to you after. So I think that the killer app for Elixir is not Phoenix, as often people say. Phoenix is just another web framework. It's a very cool one, and it's a very good one, but there's a lot of them. I think what really makes Elixir unique is Nerves. And Nerves has been around for quite some years now, but now they finally reached 1.0 last year. And so previous time I talked about it, we were still pre-release. But now it's 1.0 and it's definitely ready for all of you to play with. So as I hope to show today, it's really easy to get started and you can do a lot of cool things. So what is Nerves? Nerves is a very simple concept. How about when we develop embedded software, we could just ditch the whole legacy stack, just wipe the slate clean. And what would we put it in its place? Well, we would start perhaps with Linux as the ultimate collection of device drivers. That's really what Linux is. If people want it to be something else, that's great, but that's a good description of it. So Linux gives us the hardware abstraction layer to just about any hardware. Then let's put on top of that the Erlang VM, OTP. Who has used Erlang? 6 people will admit to it. Okay. So Erlang as a language is not very interesting, sorry to say for those who like it. But as a platform, it's rock solid. So it comes from Ericsson in Sweden originally. It's been developed for 30 years. And it runs 9 nines systems that can't tolerate downtime and need live code upgrades and just can't go down. So it's a pretty nice basis to build on. And of course, Elixir runs on top of Erlang and the OTP platform. So Nerves, very simply, is the mechanism for combining all these ingredients so that you can build cool embedded solutions, let's say, in Elixir, in a functional language. And it's actually, it sounds like it might be big, Erlang heavy, industrial kind of stack, but no. The minimal firmware image that you can ship on a Raspberry Pi or even a far smaller device than this is only about 12 megs. So 12 megs, it contains the Linux kernel, it contains Elixir OTP, Erlang OTP, your application, and a lot of supporting libraries from Nerves. It's incredibly small. And it makes sense if you think about it that Erlang was developed to run on telecom switches and to run reliably. So 2 typical choices for playing with Nerves would be, of course, the Raspberry Pi, various models, and also the BeagleBone. I like the BeagleBone more myself because the Raspberry Pi actually is a somewhat closed platform. It might be surprising, but you have to run a lot of blobs for the Broadcom Wi-Fi drivers and so on. So you don't really know what the hardware is doing. You don't really have transparency. The BeagleBone, on the other hand, is a fully open source design. You can go to production with modifications of the BeagleBone. If you're missing something, you can add it and have the Chinese manufacture you a new version of the BeagleBone. So I like the BeagleBone, but today we're going to use the Raspberry because it's by far the most popular platform. So as I mentioned, it might not seem obvious that something that people mostly use, as far as most people know, mostly use for web development could be good for embedded development. It certainly wouldn't be the case with Ruby. I mean, you wouldn't really you wouldn't really want to put Ruby on a Raspberry or a smaller device. I mean, you can, of course, you can do anything you like. It's Turing machines all the way down, but you probably wouldn't. And Elixir inherits this from Erlang, so it turns out to be very, very good for that. So I'm going over pretty quickly this general stuff. You can look at the slides later, and of course on the Nerves website. Because if you're going to do some live coding, it might be prudent to reserve time for that. So Nerves commercial products have been shipping already for a few years. I don't actually have the current stats on how many have shipped, but I assume it's millions by now. It was still thousands the last time I spoke about Nerves. So for example, here is a radar product that's running Erlang OTP and Nerves. And really, 12 megabytes means it can fit on a lot smaller board than this huge clunky thing, this modern incarnation of a PC. I didn't take with me today a Raspberry Pi Zero, but it's about yay big. It's size of a business card, and you can run Nerves on that. That gives a lot of possibilities. So let's do some live coding. And the way to start is really to do the Blinky application. It's the hello world of embedded. Let's maybe minimize the slides there. Is that actually visible? Let's make the font larger. So I have already checked out on the desktop here the Nerves examples repo, and it's got several goodies in there. Let's start with Blinky. So Blinky is very simple. The Raspberry Pi and most of these kind of boards, they have a couple of LEDs on them, and you can blink them from software. So normally when you develop on the Raspberry, you would want to connect an HDMI screen, but that's a little impractical in this setup. So we can just use this LED to see that our stuff is alive, that it's booted up, that it's doing something. And the way we would do it here is that big enough for everybody to see? If you can't see, you need to yell, and I'll make it bigger. So let me clean up this a little bit, and I'm going to remove the build artifacts so that we can see the structure of the repo. So this is our typical Nerves project. Here we have the biggest directory is the config directory, where you have target-specific configurations. So for example, rpy3 is what we're going to run. Lib, as with Ruby, that's where you put your code, most of it anyway. So here is a single Elixir source file. Then we have the equivalent of the gem file for Elixir, mix exss, and the log file. And we have our release configuration for OTP. That's not something you would normally play with too much. And then finally, we have a rootfs overlay, root file system overlay, where you can add additional files that will end up on the firmware image. And then, of course, a testing directory. So if I switch back to the slides a little bit, wrong browser. Let's see here, the edit mode. Okay, so those are a couple of terms to know. So when we develop in embedded, not just Nerves, you would normally call your laptop, you would call it the host, and your target device is the target. And you can have multiple different targets where you run your software. So for example, we can trivially make this application run on BeagleBone, on Raspberry 3, Raspberry Zero, and a number of other things. The other term to know is that the software that will be assembled as a result of this, and that we will put on the SD card over here, there's a little SD card here, that's called the firmware in this case. It's nothing special, it's just software, but the traditional name is firmware for that. So yeah, I showed you the project structure, and let's go ahead and actually build this little puppy. So the way to do it is, because I just deleted the build artifacts that I had already cached. We gotta get our dependencies again. So this is a normal Elixir process, same as a bundler. So now we have our dependencies, and then we're gonna say mix firmware to go ahead and to build it. And this application doesn't run, because it's actually controlling hardware, it doesn't run on the host. Some Nerves applications can run on the host. So we need to set here mix target equals rpy3. And so now that's in my shell session, and Nerves knows what target to build firmware for. So we try again. And let's see. What did okay, I should have done that before deps-get. So dependencies can be specific to a particular target, and indeed, as you see now, we get a lot more things. And so now we got all the stuff we need, and now I'm going to build the firmware, and then we are going to burn the firmware to the SD card. So I'm gonna disconnect the Raspberry for now, and this is, I'll show you soon a better method to do this, but this is basically what you have to do. You have to take out this little thing, easy to lose. That's a 32 gig SD card, and of course that's got an adapter to fit into the laptop, and we'll put that in. Meanwhile, the firmware has built, and we can see how big this firmware is. So we have a .fw file, and that looks to be about 28 megs. So that's pulling in a few more things on top of the bare bones 12 megs. So think about that for a second. I just built a firmware image that's less than 1,000 the size of this SD card. If I wanted to do some embedded development with Linux, a typical Raspbian install is going to be a couple gigs. So we're on a different level here. And almost any application you would make with the Nerves, the firmware is going to be less than 100 megs. So you're really ditching the bloat. Okay, so now we are ready to burn, and the command for that is very simple: mix firmware burn. And that's very user-friendly. It goes and looks at my attached volumes, and it goes ahead and finds my SD card, and then it's going to confirm that I want to wipe it, and it might even prompt me for a password. I think I adjusted my permissions a little bit. So it's doing some final things, and now we confirm we want to burn it, and indeed, I need to put my demo password here, and then we can remove the final product. So that's the old-fashioned way to develop. You have to do this 100 times a day, and this is how it was 2 years ago. And of course, this is easier for those with small fingers. It's a pretty tight fit. So let's find our power cable, and let's see. That's not going to be a very bright LED. Hopefully, you can see it. It's another small thing. Getting to the age where I'm nearsighted soon, so hard to see these things. There. And now Linux is booting up. After that, Erlang is booting up, OTP is booting up, and then finally control transfers to our application. And sure enough, there you can see a blinking LED. So I know it's not very impressive. We'll do something more impressive next. But that's hello world of embedded, and it's nothing to fear. Get yourself a Raspberry Pi, $40 at the most, and in 10 minutes you can be up and running with this. It's not at all something to be frightened of. So let's let that blink away, and I'll show you something I have been working on as a more practical application. Yeah, so actually one more thing to do is show you, that was the hard way. And now there's a much easier way. So this little board is now connected with Ethernet to my laptop, and we have a private network between us. You can also use Wi-Fi, but it tends to be in a new place. It tends to be a little bit of a pain to configure. And you can use also Ethernet over USB, which for some boards works very well. So what I can do is, first of all, we have a dynamic host name that it's set up. So I can ping my little Linux board here, and we can log into it with SSH. There we are. I'll come back to this soon. But, oh yeah, this is a special key here. Let's see if this keyboard will let me. Nope. Okay, I'm gonna kill that. Yeah. I have a few dead keys on the MacBook. As I said, I'm very frugal, so maybe I should replace it eventually. Yeah, I'm missing some key binding there. Okay, that's gonna have to be a hard kill, like that. Sometimes you have to do what you have to do. Yeah, so let's go ahead and show you the process these days. This is what I do most days now. I don't fiddle with this little card anymore. So we go back to our example, Blinky, and there we are. And now we do this. So this is going to generate a script for us. Oh yeah, I gotta set my environment because I hard killed my shell. So yeah, there we go. So now we have an upload sh script, and we can simply run this whenever we want to update the firmware on the board. It's super easy and fast. It will make it's doing an SSH connection to Linux, and it's overriding one of the boot partitions, one of the firmware partitions on the device. So Nerves has a very clever, although very typical in embedded space, clever partition layout. You have A and B partitions for your firmware. That means that you can flip between them when you do upgrades. And if your upgrade, for some reason, kills the board, you can switch back to the A or B, the other firmware, and recover from it. So that's the way to develop now. It takes a couple seconds to do a new firmware, and you didn't catch it because it was on the table, but the board rebooted and it's still blinking away. So that's good. So that's the gist of it. And looks like I'm taking a lot more time than I thought, so let's move ahead. So this is what I wanted to show you guys today. It's definitely a work in progress. It's got rough edges. I was trying to kill one bug today just before the presentation and didn't. So it's definitely got a few bugs. But let's do a little bit of a demo. So I'm going to burn another firmware to the Raspberry. That's going to take control of the camera, and we're going to do something interesting with that. So I have a little project here, and let's go ahead and, in this case, I have an actual, so this is just setting the same environment variable we just saw, export mix target, and we're going to build this project, and then we're going to burn it over the air to the board, and then we can do something cool. So let's see if this works. Fingers crossed. And I'm going to also have a special guest appearance of my lovely wife and Pivorak baby. So hold on for that. So yeah, the build process does take a little bit of time. Still, it might be a reason to have a faster computer if you do it 100 times a day. So this is a little bit of a bigger firmware image. This is actually, I based it off something called FarmBot, like farm robot, an American company who are developing very cool automated farming robots based on Nerves. And their base image for Nerves, it's got some good stuff for computer vision because they need to differentiate between the different kind of plants automatically. So I used the base image, and it's a little bit bigger now. The firmware is even 47 megabytes. It's huge. And let's upload that. I think I already have the upload script here. So we are upgrading partition A. There it goes. And now the board is booting. And since I don't have an HDMI monitor, in this case too, I'm going to rely on when it starts blinking. I have a special addition to the firmware that it will do a heartbeat pattern, so I know that it's alive. It usually takes about 10-15 seconds for a Raspberry to boot. Some other boards are faster. That looks like a heartbeat, probably too small to see. Okay. And then we are going to connect, Nerves local. So this gives us an interactive Elixir session to the board. And here we can see what's happening, for example, with the log. So I'm going to attach to the log stream, and we can print all the log messages that were already output. So for example, we see that it got a network interface with the HCP from the host. Now what it's doing is it's actually capturing live video here, and we are doing a little bit of face detection and recognition. So let's have a look here. We have a camera client that it's a little heavy pig to start, but it's Python. It'll start soon, and that will actually let us see something. Yeah. If I wrote it in Ruby, it would be even slower, so yeah. Let's make sure it's actually, lost connection, okay, what's going on here? Yeah, okay, I need to, it defaults to localhost, I need to say Nerves local, of course. I probably should have done the other default on that. And let's try that again, okay. So here we have a live video stream. This is super dumb and quick and dirty. I'm basically streaming JPEGs. So I'm just grabbing frames from the camera and streaming JPEGs. And I'm not sure, so this is an interesting test. I wasn't sure if it would crash here because we are doing face detection and there's a lot of faces here. I didn't have 100 people to test with, but looks okay. Probably because you're so small over there. So let's see, yes, that's better. And let's invite my lovely wife and Pivorak baby number 1, and let's see what we can do. This is Maria and Enkeli, and let's have a look. It knows Maria. Does it know Enkeli? Yes. So that seems to work pretty okay. So that's something you can do with Nerves. So, Anna, how much time do I have? 5 minutes. Okay. That means we are going to a little bit run through the implementation. Let me kill the client. And here, this is the bug I was trying to fix today. I have a no function clause matches. I need to find that. So as I said, this is a security system. I would like to eventually deploy this at my garage, my office, my home, and perhaps beyond. And let me quickly run through some of the highlights. So we already saw how to connect to the remote console. There's very cool remote debugging we can do with Elixir. It'll have to wait for another session. There's local GUI-based debugging tools that we can use to inspect the process. We'll dig into that another time. Technologies I'm using here, these are probably familiar to most of you. I highly recommend, especially for people who are interoperating between languages, to check out gRPC. It's a very good polyglot technology, let's say. So in this case, it's a Python client talking to an Elixir server. So the camera driver here is a, so here's actual code. I wanted to show live coding. So the camera driver here is not very long. This is controlling a C++ program that's actually doing the computer vision under the hood. And the idea with Erlang and the OTP platform is that you absolutely do not put unsafe code into your safe memory space. So anything you're going to do with dirty languages like C and C++, you do that in a subprocess. And if that subprocess dies, who cares? You'll respawn it and off you go. That's a very, very good way to build reliable software. And the Erlang platform will stay up without any trouble. So don't have too much time to delve into particulars. I will mention that this is, for those of you who have used Elixir and maybe played with the state machine support, it's a very nice use case for Gen state machine. Because of course what we do is, first of all, this is a state diagram of the siren. So a siren can be on or off. It's very simple. It's either making sound or it's silent, and can transition between. But then you can also model the whole alarm system as a state diagram. This is not finished yet. This needs a little bit more work and thought. But you can see here, for example, that when you have an armed system and it gets triggered by somebody climbing in the window, countdown starts, and eventually a timeout is reached because there was no authentication, and then we have an intrusion. So we move into an intrusion state. And then we would start the siren, for example. So I can, after the session, I can give more details to those who are interested. I think we are probably pretty short on time for the particulars. We also have an API. It's a very simple home API here that is defined using protocol buffers and gRPC. So that's the interface definition for the API. And that's then code generated into Python, and that's code generated into Elixir and into Ruby if you like. And it means you can write scripts and programs to interoperate with your alarm system and home server. And yeah, there's a lot to say about face recognition, but maybe that's another talk. So have a look at Nerves if you're interested. Hit me up if you have questions. And for those of you who are not into Elixir but maybe into Go, I've recently become aware of this project. This seems to be inspired by Nerves, or at least very similar. So I haven't tried it, but might be cool for those of you who are into Go. And Jakuju. Right on time.
Thanks, Arto. We have time for 2 questions. Guys, just raise your hand and say your name and then ask the question. Okay, any questions?
Hey.
Hello?
Yeah. My name is Vadim. Have you tried to connect your alarm system to some locks? I don't know, some door locks?
Not yet, but I'm very interested in that. I hate how many keys I'm carrying around. And even though, of course, we all know about the Internet of Shit, and we know what happens when these digital locks malfunction, as with the recent case with the Nest thermostats and locks, I think we need to move to digital locks. So I'm exploring that as well.
One more question.
Hey, Yaroslav here. Great talk, wonderful software, at least it's what it evolves to be. I'm wondering, with face recognition, do you need internet connectivity, or are you using any online services like Amazon or anything like that? to do the face recognition, or is it done everything inside of the Raspberry Pi using your algorithms on board?
This is fully offline. This is using something called FaceNet, which is a research paper and result from Google. So it's a deep neural network that uses one-shot learning. It means that instead of the usual tens of thousands of images that you have to give a typical neural network for it to learn, there's already a base data set, and you need a single picture of a person that you want to, for example, authorize for the alarm system. So this system had a single picture of me, a single picture of the baby, and of my wife. And that's enough to get 99.8% accuracy.
Impressive. Thanks.
Indeed.
Thank you so much. It was a great demo today, and we have a special present for you, Arto.
Oh. Dякую.
Thank you so much. Round of applause for Arto.